Hi, I am Ashish Tanwar and I want to give a brief introduction of the project that I developed for the SIGCON 2014. The project name is Flow Simulator and it is a simulator that operates on the network flows. So the software I developed in Python. So I want to give a basic overview of what software is and what it does. So I have created a folder called com world submit in which I have put all the code required, and I have created a Word document in which I am giving all the required information for installing and running the software. So this project was developed in the guidance of three professors, Professor Vyas Sekhar, who is currently professor at Carnegie Mellon University, Professor Samir Das, and the Professor Himanshu Gupta. And this flow simulator was built on the top of a basic flow simulator developed by Joel Simon at the Colgate University. I am constantly in touch with the Professor Joel, and we had some planning about developing this project. So this simulator, basically what I did, I designed my own traffic generator that reads the input from a traffic file. This is the basic format of traffic file. It has four fields. One is the flow start time, the source router, the destination router, and the flow size in bytes. And the present experiment, the default experiment, is having 24 nodes from H1 to H64, and the simulation has 3.7 million flows. It takes around 1 hour on our Savit server that has 64 cores, and and it takes around 4 GB RAM when it is running. So this traffic flow, this traffic matrix has a particular pattern, and it is automatically developed from a Perl script called that is placed in code directory called generated traffic fs.pl, and basically it generates traffic as per its particular topology. Either it is jellyfish or it is a big tree or other topology. So so now I will give you file structure of my project. So this my correspondence is Professor Joel Simmons, and let's go to the project. So this is the project directory. If we do it ls, as we can see, they are graph files. The graph files have the topology information, and here all the C++ logic is there that correspond to the forwarding decision taken. So we have developed this project for three simulators. One is HTSim, second is the Mininet, and third the Flow Simulator. So we have the common logic that operates on all three simulators that is written in these C++ files. And since our Flow Simulator is working in Python, we have binding between the C and C++ Python written in the Boost C++ language, and there are some GNU plot script that gives us the plots of the results. So I have the basic readme is there, and this is my readme, and I am creating a Word document so that you can directly run the experiment. It requires basic Python and some Python modules. So let's go to the conf directory. So this is the directory where we have to run the experiments. So as you can see, there are different files. So these there are flow files and the counter files that corresponds to the flow level details and the total counter count on a particular router. So yes, presently all files are empty because new experiment always overrides the old experiment. So I can check, I can show you the format in this file. So there is some file in which I see some data. This is counters. So as you can see, it has data, counter data, that what is the flow start, what is it is like, it is generator, from generator it is going to particular router, how many bytes are transferred, how many packets are transferred, and how many flows are transferred. In parallel, we have a uh, flow file that have minute details of every flow going through that router. So if we open that file, we can have minute details like what is the router, what is the flow start time, what is the flow duration, and what is the IP address it started, what is the what is the destination IP address and port, what is the protocol, whether it is TCP or UDP, what is the protocol parameters, whether it is generated from a traffic which or from a node. So basically it is generated from a particular traffic generator called matrix that I had developed, and then whether it is TCP protocol 4 or sorry, IP protocol 4 or IP protocol 6, then it is flow size, and they like TCP TCP signals, like if it is acknowledged or completed or still in progress. So uh, so let's go to next. So for running the experiment, we have to give the command sudo python traffic logic input.py. There are some files in parallel that are for different functions, but this is a very simple function that can give the basic experiment run, and in parallel I am running the experiment. As you can see, it will take around 1 hour to complete. Let's see how much percentage it is completed. If I do a toke command, I can see that here it is taking around 4.2 gigs of RAM, and it is utilizing presently my 96% CPU, and the CPU I have the lab access. The CPU has 64 cores, so, and the running time is 46 minutes. So it is about to be completed. So now I will show you the how the bindings are done. So I have given you the introduction about the input file and the script that generates it. Then I have given you the introduction of the output. I have given you the introduction of how to run the experiment. Now how the traffic where I want to give the introduction of the traffic flow. So how we basically forward the traffic, where the traffic decision, and the traffic decision in the file. This is okay. So, sorry. So there are these C++ files in which we have put all the traffic logic. So main file is this traffic control logic 2.cpp that has the base logic of forwarding the main flows. There is a second file, that traffic network controller logic to flow, that is specifically for forwarding the elephant flows. So if I open the file, this is the Python bindings. This is the Python bindings of the C++ library, and these are the all the code written in the STL, that is mostly written by Navid. If I move forward, some part was contributed by me, and if you can see there are different functions here in the class network controller logic 2, like initializing memory, and like is connecting, checking the connected, initializing. There is a particular initialization for the mininet. As I told you, this flow simulator, this control logic works also for mininet. Then initialize fs, that is my part. So this is the this is the part that is basically going to initialize the flow simulator, and now I will show you the bindings. So there is very simple boost Python bindings in the top, at the bottom of the files. These are the bindings. So basically I am exporting some data types from C to Python, like map, like string, like some complicated structures in which we have map of string of int pair and string int map. I am naming that, and other these different bindings I have created these bindings, and I have exported all these bindings. So this part was done by me, and after that I can show you how these bindings are working. So let's take one example, like elephant flow arrival and elephant flow end. So let's go to the file. Okay, so main logic in the fslib directory, in which all the code I forget the directory name in which I had so I have so as I remember, I have my traffic generator code. My basically traffic generator is placed in this traffic generator folder. So in this traffic generator folder, this is the file matrix.py that was written by me. In which basically I am importing all the functions, and this is the file that I am taking input from matrix, input.matrix. Basically input.matrix is the corresponding file to the traffic64 file. And if I go down, here these are the bindings that I wanted to show you. That as you can see, I am basically using the C++ object network controller logic 2 object, and I am basically updating the flow volume and flow volume in transit and other entries, and I am basically checking. As you can see, these prints, you can see that these prints are being updated and printed on the screen when the experiment is running. So this is all about the flow simulator. I hope you will be able to run in, and in case any problem you can contact me. So since the installation and other procedure takes time, I hope this introductory video will help you. Thank you. Thanks a lot.